Hi everyone, welcome to this section, moving millions of dollars daily with Ruby while still be able to sleep at night. I just realized it's a quite long title. So before we get started, I actually have a secret to share. In my programming career, I have not only written code, but also bugs. Actually, lots of bugs. More than 3 bugs. More than 6 bugs. Maybe as many bugs as this slide can fit in. I try really hard to write bug-free code, but sometimes there were still bugs. You can't get rid of them. When my bug was found, I would be like, ouch, that's not fun. Some bugs may or may not have customer impacts, but most of the time, I can fix it pretty quickly, and life will be fine again. But then something changed. I joined the payments team, the team that moves money, lots of money. How much money, you may ask? Well, at Gusto, we have over 16,000 customers, and we are moving tens of billions of dollars annually. That's on average, hundreds of millions of dollars daily. Including me, we have 4 payment engineers. So on average, each engineer moves tens of millions of dollars daily. That's a lot of money. Now deploying code literally means moving money. And then I also remembered I have written lots of bugs in the past. Ouch. Now it's way more scarier. So I asked my manager, what should I do? Should I quit? I don't want to cost the business millions of dollars. My manager said, don't quit just yet. Read this book. So I opened the book, and it says, 知己知彼，百战不殆 from 孙子兵法, which in English means, know yourself and know your enemy, and you will never be defeated. From the Art of War, an ancient Chinese military treatise. My manager explained, it is not about writing bug-free code. It is about knowing that there will be bugs. Wow, so that was my moment of enlightenment. Before we go on, let me introduce a bit about myself. So my name is Sihui. I work at a startup in San Francisco. We are building an all-in-one platform for payroll, HR, and benefits. I first started as a full-stack engineer on the HR team, building customer-facing features. And now I'm an engineer on the payments team, building systems that move money. On my free time, I also blog about Rails and Ruby and design systems and other things I learned at work. So this talk is about how to build a mission-critical system that's trustworthy, knowing that there will be bugs. What I'm about to share can fall into these 3 categories: general engineering best practice, how to use chatbots to monitor and alert about the system, and Sidekick best practices. All of the lessons I'm about to share are what we learned as a team over the years, and we documented them as internal wikis. Credits goes to all the engineers at Gusto, and mistakes are mine. In case you wonder, we're also hiring. I figured the best way to convey most of the lessons is by going through a worst-case scenario together. Remember, our premise is that there will be bugs. So we should expect bugs and be prepared for them. When it comes to handling money, what's the worst that can happen? Is it losing money? No. It is losing money without knowing it. Imagine one day, your company receives a call from the bank telling you that there's no more money left in your company's bank account. That may be the game over for the business. Losing money without knowing it will also cause customer trust. Without customer trust, there can be hardly any business. So how can we prevent this from happening? Here is where we use chatbots. We use them to monitor and alert about the system and tell us about what's going on. Each time we run a maintenance, a chatbot will alert the maintenance channel, telling us how the detail of the money being moved. We also have alerts on the company level. If a company we serve have outstanding balance, the alert will notify the operations channel. So folks on the operations team can take a look and make sure things are under control. Now with these alerts in place, what happens if an alert goes off and tells you there may be a fire? For example, if the payroll maintenance failed, it's going to notify the engineer on call directly. What's the worst that can happen in this case? Let's ask ourselves this question. Would you rather have a small fire like this? Or have a big fire that burns the whole house down? On the left side, it's on the right side. On the right side, we have a big job that moves tens of billions of dollars. Whereas on the left side, we have lots of small jobs, each may just move thousands of dollars. Failing at the job on the right side is going to be way scarier than failing a couple small jobs on the left side. Wait, left, right. And then you get the idea. So this is what I mean by having a big job. In this job, we first get all the companies from the database and we load them into memory. Then we iterate through each of them. For each company, we're going to move money. If for some reason the job fails in the middle, it's really hard to tell which company's money have been moved and which haven't. And recovering from this failure can be quite difficult. In this improved code, we first get all the company IDs from the database. Then we use Scikit's push bulk method to spin out each individual jobs for each individual company. In this case, if for some reason the server goes down, some jobs may have been succeeded, some jobs may have been failed, but it's going to be really clear which company's money have been moved and which haven't. And recovering from this case is going to be easier. Here comes our first Scikit best practice, which is never iterate and keep each job small. Always trying to break down big jobs into the smaller ones. Now, instead of having a big job failing, we have a few small jobs failed. It is time to debug and figure out what went wrong. In order to move money on time, we need to submit the files to the bank by 5 p.m. each business day, which means that we don't have the whole day sitting around to figure out what went wrong. We need to have a fast way to debug and fix it soon. So how can we make debugging easy and fast? This is our first general engineering best practice, which is to be defensive and raise error as soon as something unexpected happens. On the payments team, we use the contrast gem. We use it to specify the type for the passing argument of a method and the expected return type for the method. If the method is being called with an unexpected passing argument, or if it returns an unexpected type for the result, the gem is going to raise error immediately. For errors that cannot be called by the gem, we're going to check it and raise errors explicitly. It is better to raise an error as soon as possible than let the error slip by and maybe down in the line a few methods later to raise the error back there. Because if you raise an error later, the error message is going to be a few levels away from the root cause, which may cause debugging more difficult. You need to think about the outside world, outside of your method and classes, as the Wild West. It is quite dangerous there. There's no guarantee about how people are going to use your classes and methods. But inside your method and classes, it needs to be an exclusive club. It is very important for us to prevent any unsupported or unexpected data passed through our methods. Protecting data integrity is critical because recovering from polluted data tends to be very expensive and difficult. Another best practice we try to follow is to be clean, to embrace the single responsibility principle. Be clean means to only do one job at a time. A class should have one job and one job only. If a code is clean and simple, reading it and debugging it can be easier. So now, thanks to these two best practices, we are able to locate the bug pretty quickly. It turns out it was because there were a few companies' bank accounts information was incorrect. So we corrected them. And now we want to rerun this Sihui job. Here's another Sihui practice we follow, which is never save states to Sihui. If in this Sihui job, we pass the company inside, what's going to happen is that all the parameters for the company is going to be serialized and saved to the database, and saved to Redis. So even though we may have the correct data in database, we running the job, we still use the cached outdated data. And another downside of using this, of saving states to Sihui, is that Redis is not a reliable data store. It may go down anytime. And the process of serializing objects into Redis can be expensive as well. So instead, we're going to pass in the company ID to the job and let the job to fetch the company later when it actually gets run. We also try to keep our job idempotent and transactional. Being idempotent means that running a job once and running it 1,000 times should have the exact same result. And being transactional means a job is either succeed or fail. There's no in-between state. Because of these two practices, we have confidence to rerun a job as many times as we want. Now we rerun the job, and those failed jobs are set. And we can see an alert in the channel that says payroll maintenance was a succeed. You may have noticed not all the alerts are the same. Indeed, we have different levels of alert based on different levels of urgencies. If it's a critical error, the alert's going to ping the engineer on call immediately, so timely actions can be taken. If an issue is not that urgent, but still worth attention, the system may create an investigation ticket and alert the operation channel, so the operations team can take a look. It is very important to have different levels of alerts, so alerts that require immediate action won't get buried by noises. Here are all the lessons we just went through together. And there are 3 more I want to share. The first is the 1 query per job rule. Most Sihui jobs will only have one read query and 1 write query. This is along the same line as trying to keep each job small. Because the database is really good at parallelizing works, we should take advantage of it by splitting separate database operations into separate jobs. Another practice we follow is to not hammer the database. If we know there's a big batch of heavy, long-running Sihui jobs, instead of trying to start them at the same time and finish them as soon as possible, we would want to spread them out over a period of times. For example, if there are 10,000 heavy Sihui jobs, instead of starting them at the same time and trying to finish them at the same time, we may spread them out over an hour or 2. So these heavy jobs won't exhaust all the resource, such as overloading the database and bringing down the database. Because a payment system is essentially an accounting system in a different form, the system needs to be able to tell us what are the balances on the book at any given point of time. It is very important for us to keep all the data there. That's why we embrace the immutability principle, which means we tend to not modify or delete any data. If we realize there's some data that's incorrect, instead of trying to modify it in place, we may create a new record of the data and have a newer effective date, so the system knows that it should use the latest data instead of the old one. If a record shouldn't be in the system at all, instead of directly deleting that record, we may just create a reverse version of that record to cancel out its effect. By following the immutability principle, the fact that there was some inaccurate data in the system at a given point of time is being captured. And these are all the practices we just went through together. Here's when you should take a picture if you want.
Please feel free to take photos and hashtag RubyConfTW.
And you can add my Twitter account token too, which is on the corner. I'm not going to say the right or left corner because I tend to mess that part up. Some of these lessons may not be applicable to the system you're currently building. But the main point I'm trying to make here is that we should always expect the unexpected, because we are all fallible human beings. No matter how hard we try, we're going to make mistakes every now and then. So instead of betting on our code being 100% correct all the time, we should expect the unexpected and plan around it. A reliable system is not a system without bugs. A reliable system is a system able to get its job done in spite of bugs. You can find the slides and notes at sihui.io/millions-ruby. You can also reach out to me via email or Twitter. I also recently gave another talk that's called Ouch, That Code Hurts My Brain. You can also find it on my website as well. If you enjoyed this talk, you may like that talk as well. Thank you.
Now it's Q&A section. Do you guys have any questions? Hi, please use the intercom next to you.
Yeah, I want to ask that you say you can sleep safely at night, right? So I want to ask if you have any system for auto recovery or auto healing system. So say some error occurred, you'll automatically to try it again or something like that.
Let me see. Because our system actually is, we use it to move money. So if something wrong happened, we don't want to just like auto recurve and like automatically move the money again. But we do have a system that's somewhat auto healing. That is because our company is dealing with different banks in our internal bank account, and we try to have certain percentage of the money distribution between these two banks. So the system is like self-monitoring the distribution of companies' money between these accounts. And if one bank account has more money, the system will automatically try to move some money and distribute it to different accounts.
Okay, thank you.
Yeah.
Do we have more questions? We got plenty of time. Yes, gentleman from the back.
So you use Sidekick for background jobs. Why Sidekick? Why not any other? Why did you choose that one?
I didn't choose it, but
Okay.
but I think Sidekick is the most popular one in terms of the Ruby land for job processing. Yeah, and it has quite good support as well, and it's also open source. So.
Okay, do you have any questions? The guy in red? Yeah, that's you. Yeah. No question? No, okay, because I saw you with your hands up. Okay, we still have plenty of, oh yes, a gentleman from the back.
Yeah, so when you have actually encountered, when an error has occurred, what is the longest time that it's taken from noticing the error to resolving it? And has that sort of period ever caused any problems for you?
Because I haven't been in the company since it was born, but based on the time after, I'd say sometimes some error do took some time to surface out, because if an error from our definition is not really urgent, it may just have create a bunch of investigation tickets in the background and have the operation teams to take a look. Sometimes if the operation team or like we misjudged and didn't think there was a real error, but the investigation keeps coming up, and then later realize, oh, it's actually a real error, then the loss will be longer if we didn't like catch it earlier. Yeah, so the faster we were able to discover the error and fix it, the less money we may be exposed to loss. Yeah, definitely not.
Like maybe a better way of asking that question would be, what percentage of these error messages do your customers wind up noticing?
Not so much. I think the last time the customer actually have like a pretty direct impact was 2014 or something. Yeah, because if it's an error on our side, our company would take responsibility for that. So most of the time it won't impact the customer directly. But we still try to prevent that because it's a loss in our company's finance.
Good? Yes.
Kind of to piggyback on the question of like how do you resolve incidents once they happen, I was really impressed with at the beginning the repos for the content where you are sharing learnings within the company. Do you at Gusto have like run books or kind of a plan for when certain incidents happen, and what do those look like?
Yeah, definitely. So we have engineering on-call rotation. We call it VM Viking Master. And within the payment team, we do have a Viking Master playbook that tells you here are things you should look out for. And here is like what you should do if this is the case, just to onboard engineer faster. So like here's step 1, step 2, check this. If that's the case, then it's maybe not a big deal, but here's what you need to do. Yep.
Okay. Do you have any more questions? Please use the intercom. Can you just turn on the switch?
Can you hear me? Okay. So according to your recommendation that we should split the task into a smaller chunk, does that also cause as a side effect? So say, for example, some task, when you spawn the task on Sidekick, actually that task will get the connection of the database from the connection pool, right? And now by splitting the task into a different chunk, does that mean that there should be like a lot of rotation on the connection pool, that you have to do more job in order to pull the connection and use it? So I just think that perhaps that will cause a side effect on the performance issue as well.
I think in general, Sidekick jobs are pretty cheap, and the database is really good at prioritizing works. So, but definitely there is a balance you need to strike between how small you want each job to be. You don't want to, if it really based on the context, in the example of moving money, maybe it doesn't make sense to break it down to maybe each employee's level. So like maybe you can just break it down to this job is for moving money for this company. Instead of moving like each dollar you have a different job, then it may be too much. Yeah.
Okay, thank you.
Great. Do we have any more questions? No? Do you have anything else you want to add?
I think one key point I really trying to make through this presentation is to expect the unexpected. One lesson I learned was back when I was still on the HR team, and I made a mistake in the code, and then the data get polluted. So because the data that get polluted was also related to customer data, and we need to try our best to recover it. But because it's polluted, it's really hard to recover those data. It took me and my manager like almost a week to just recover that part of the data. And one thing I really learned there was that when you deploy a new system, instead of just thinking, oh, the new system is deployed, I have tests, I'm done, I can move on. You really need to think about what is the worst that can happen, and then you need to plan around it. So instead of deploying and then move on to the next thing, you may want to stay around and monitor and make sure everything goes smoothly. If not, you may be able to catch it as soon as possible. And I also want to add that like having bugs in your code is inevitable. So our goal shouldn't be trying to 100% bug-free code all the time. Like that's what we want, but it's not realistic to back on that. So if we could get over that hurdle, that pride within ourselves, thinking we have to make sure our code is 100% bug-free, then we can be more realistic and plan around that. I think that's it's more like a mindset thing than anything, than any like specific skill, but it's a mindset. Yeah.
Great. Thank you for your sharing.